Thanks for joining early, Winston.
Yeah, I just want to make sure I didn't yeah.
Yeah, so the meeting on Wednesday, I think, worked out really well. And, it generated, I think if you look at it, was followed by Broadcom said, hey, I could really use a schema. A number of people said Redfish, and then you saw John come back and say, I don't think it's really a fit. But, I think as we start to look, and what's good is, hey, we've looked at Redfish, we've looked at Yang models, we've looked at this, and we're kind of doing it in the context of AI, as opposed to, hey, we didn't look at anything, we're starting over. But definitely there seems to be a real interest, and that's a good thing.
Yeah, and I think even for Redfish and some of the open config stuff, right? I think it's like really, I mean, the way we kind of look at it is like they're kind of complementary,
Yes.
right? You could kind of tie whatever their schema, attach it to one of these things we kind of,
Well, I
define in
mean,
the infrastructure. So
yeah, because at that point, if you look at, you have a device, you don't want to go into the bowels and the bowels of the device. They already do that.
yeah.
So you could even link to it and said, hey, okay, we have this. Well, what's this? Well, we have
Yeah.
an entire Redfish model of that.
Yeah. Yeah, because my worry is just like I think even John mentions like, they try to actually get the switching guys, the networking guys to actually define everything in Redfish. They build a translator and then there was no takers, right? Actually, people
Yes.
use it. I think that's the problem when people try to just kind of converge it to one schema, be the
Yep.
for everything. Is like if you could compose it, make it flexible to bind to each other, then you know
Yep.
it's very
Well,
good.
and if you look at it, so people are definitely, hey, get it out there. Let's get something, get it in writing. And Rob's like, we definitely have a home for it. So once we get started, we can figure out what's the right place to do it,
Yeah.
whether it's part of the server project or part of a different project or things like that. It wasn't like, hey, we have no interest. We have a lot of interest in, and I think people want to make sure it kind of goes the right way, which is a good thing. It's a good place to be.
Yep.
So,
Yeah, we're gonna need your help to kind of help us guide this, right? And then we could yeah, see where
yep.
it lands.
You're the only topic for today. So whatever, we're going to spend 5 minutes, what it usually takes us to get started. And
Okay.
then however long you want to take, if you end early, you end early. I'm not interested in time filling today. So,
Okay. I
okay.
mean, all right.
But, and if you want to add the color of the comments from the open, so this is really kind of reading out, hey, we did the demo, we presented to Open Systems for AI. Here's the kind of thing, hey, we got this feedback, here's the pieces, here's kind of our space working forward. Kind of fill people in, catch them up, go through that'd be great too.
Okay.
As you were saying at the end, it's really a call to action. But it's not begging for participation, okay?
Hi, Jack.
Hi, how you doing?
Good. How are you?
It's good. It's Friday. I was just telling Winston, it's Friday.
Yes.
So we essentially just have this topic, kind of the readout from the Open System for AI and kind of the plan forward for today and really nothing else. So
Okay. Do we have an update from each work stream?
so we don't. We'll probably plan that for the next one. And maybe that'll be kind of the action item that we'll go through Wayfang. So we'll
Okay.
if we want to send that out and say, hey, here's the work streams, here's the pieces, let's do the update in terms of that would be good, because it gives
Yeah.
people a chance to kind of, here's where we are, here's what we're doing, kind of thing, but that would be great.
Yeah, that sounds good.
So we'll schedule that for the next one and then um and then use that time for the next one, because I'll have an update. I have a data services document I've filled out. I've gone through a lot of spaces. So my part, and then the ML Commons team is starting to look at this storage working group starting to look at storage. So they're kind of booked for this Monday, but the following Monday. So there's a work group that kind of spun up around some of the, how do we model some of the storage data stuff? So that'll be good too. So we'll have an update from there.
Yeah, that sounds great.
Okay. So we'll give it a couple minutes to get started here.
Just so you know that I created a document. I actually didn't get a chance to present at the tech group meeting yet, but I did talk to another community, Julia, about how to aggregate matrix. That their comment is it is definitely a good thing to have. However, it's because of the current profile is library is vendor specific, other than I believe AMD. That's why it's hard to have a kind of a more detailed real-time matrix.
Okay. So Weifeng was talking about 2 weeks from today, kind of doing an update. So we'll kind of, Weifeng and I will kind of gather, and Victor, it'd be great if you have kind of an update in 2 weeks.
Yeah.
Okay, that'd be great. And then Yasha, I'll send you a note, but on the semantic distance thing, I met this morning with my advisor, and I think I've got a real close plan in terms of this. So hopefully I have a model that I can show you in a couple of weeks as well.
Sounds good. Sounds good.
So, okay, so we're gonna give it one more minute to about 5 after. And then Winston, for today, Winston and team presented to Open Systems for AI around the schema, and some of the things they've done and kind of the call to action. So we thought we'd use today to give a readout to the team, what was presented, what's some of the color, so the comments, what are kind of the next steps, and what's the call to action. So Winston, I'm going to go on mute, and you guys can kind of take charge in terms of this, but we'll finish up with, how do we collaborate? What kinds of things do we do? Where do we go? And from that point. So Winston, it's all yours.
All right. Are you guys able to see the screen?
Yes.
Yeah.
So just a quick recap, right? Like I think I think maybe at a month or a month and a half back, right? I guess our team actually did a presentation or a demo, right, of showing that how we could tie some of these sort of like a standard schema, right, to be able to define like the blueprint of what a AI infrastructure or cluster looks like. In addition, with that tie into elements from ML Commons Chakra, right, to be able to describe neutrally, the sketch of a workload, right, and then combining them together, how you could actually drive, various downstream tools like, open source simulators like AstraSim to do, what if analysis, right, or when you're designing new systems, as well as like, now that because there is a more standard and unified way to define both the infrastructure and the workload. We're able to then take that definition that you feed into simulation and be able to, shift, either left or right in the development cycle to, whether it's like a network emulator in physical form or even real devices, right? So I think after that, like, Jack set up this, presentation for us to actually talk about this to the Open Systems for AI, where they have a monthly meeting, right? I think that it was like 2 days ago where we presented the similar ideas about this whole, we need kind of like really a standardized definition for AI infrastructure where it's machine parsable, right? Where it's not just, really pretty looking graphics that shows how the racks are connected, right, in slides. But it's really machine parsable where you could actually enable a lot of these downstream what if scenarios and for different tools. So this is the deck that actually we use to present the stuff, and then we'll go over it in this meeting, right, with everybody. But generally, like during the meeting, I think there's people engaging, right, asking questions about, for example, like, have you considered doing the schema with Redfish? Or and there's like another presentation that follow us, right? Who's designing a new sort of rack system, right? From more like the networking vendor perspective, on what that blueprint for the rack or the cluster would look like, right? And felt that, hey, this thing could actually help, defining the actual blueprint in a machine parsable way, right? And then the redfish comment was more to do with, I think the gentleman was actually more from, somebody who's very familiar with the details of how to manage server systems and then be able to configure it, give visibility from it. That's kind of what redfish was intended for, right? And I think it's like, we will be engaging, those folks to go deeper into it, to really try to, sort of delineate kind of like what we're trying to describe here is not to that level, right? In terms of all the details, nitty-gritty of all the individual knobs or visibility that you have within redfish and try to reinvent that, right? So I think it's like the general approach is like, we're trying to, we're going to work with the community to figure out, like, make sure people understand that, you really, just like we're composing different components, a lot of these schemas, should be actually be composed, right? Where, this infra.proto is kind of like the glue that could actually give you a, blueprint of what the cluster, logically what the cluster looks like. And then you should be able to bind, other standard schemas like Redfish or even OpenConfig for networking switches or routers to that infrastructure, right? And then just use those format, right? It's not about redefining everything and shove it under one particular, standard and stuff, right? So I think that's the main takeaway from it. And I think, and I think, Rob was actually the host, right, for the Open System for AI meeting. Was interested, like in seeing how, this work could be actually sort of, like move forward, right, under the OCP umbrella. So we'll, so I think it's like, I think overall the reception was positive, right? It's not like, oh, we have no interest and things like that. So I think we'll share it with this group, and then we'll work with Jack and everybody here to figure out, what's the right way forward and how do we land this. Okay.
So how key sites use this schema for your test and measurements tools?
I'm sorry.
Keysight, how it uses this schema for its
So I
test and
think
measurements.
so Hesham, like I would maybe let's take those questions like at the end after we go through this presentation, because
no problem.
I want to talk about more the schema, right, that benefits the ecosystem, not so much about Keysight. Okay, so
That's good.
all right.
Hey, Winston, got a question. I know you present this at OCP meeting, so in the future, is this going to be part of this co-design project, or is going to be a standalone work stream?
No, I mean, I think that's the part that we need to work with you and Jack, and also to try to figure out how we gonna go about this, right? And I think Jack's initial I think feedback was that, you know, we could start here, right? Because a lot of us here, I think it's more wearing the overall system co-design hat.
Mm-hmm.
And that may not necessarily be the case, right? Like for people who are really focused on, you know, shipping a switch or shipping a server, right? From the perspective of like, I already have a rack design, I'm just gonna ship it for for people to consume, right away and things like that.
So
So
Weifeng, I think to Winston's point, when we ended, Rob said, hey, we'll have to find a home, so we could go tin cup in hand and go around to all the groups, or we could raise our hand and say, let's start here. It's nice that we're part of the server team, because the person who's also leading Redfish outside of OCP is John Leung from Intel and part of the server team. So we're a sub-project to server. So that's actually quite good. And then
Okay.
have to reach out to some of the network. There's no one home that kind of fits. And then to Winston, what Winston was saying is right after this, Broadcom did a presentation on building templates. So could they do blueprints? And if they could define the blueprints in such a way that also rendered to a schema, which then could drive to a modeling simulation kind of thing, and then it actually fits in, and then it also could render into a management tool, which looks like Redfish. So it starts to create the connection. So the Broadcom person doing the blueprint presentation was extremely excited about having a way to take his pictures and turn it into like a much more of a programmatic way. But John is part of server, we're part of server. Other people who are looking at fabrics and things like that, especially like CMS, things like that, are part of server. And so I think it would be good, but we'd have to raise our hand. So Weifeng, if you look and say, I absolutely do not want these Keysight guys anywhere near, then we'll have to speak up. But for right now, we volunteered to be the home.
I think
Yeah,
one of the things is there's a lot of people trying to do different things here, and it's going to be hard to wrangle them. So, I mean, what I've been looking at in the last couple of years is using federated approaches to things, where we give people interfaces so that things can talk to each other without trying to shoehorn people into one standard.
yeah, and I think that is the approach we're trying to take here, right? Because it's really, we're lacking that language, right, in order to bind the different parts together.
Yeah, I'm trying to get the guys at the Open Atomic Ethernet work
Sure.
stream to sort of create a network description language for doing their networking stuff. And I'm getting pushback on that. So it's like, that seems to be a missing piece.
yeah, certainly. I feel like this group definitely have a lot of interest to doing that, especially in the polymorphic definition documents. We do need a certain type of kind of a schema to help us define those infrastructure. Actually, we did, generate some kind of a JSON-like format, but those things are not really systematic. But with this type of a schema, I guess we could have a more complete description about our polymorphic architecture. So it's definitely valuable to us. So, I mean, if there's no other work stream or work project trying to do this, and then we certainly can raise our hand to say, okay, we can start from here.
Yeah, I mean, I think that's definitely like talk about that at ongoing, right? Because we're definitely doing it. So yeah.
I think you can take it as an all microservices view of the world if you want. So
Okay.
try and normalize it.
Yeah. So I think maybe let us quickly walk through this slide that the deck that we did for them, and then obviously like the slide deck will be available for everybody after the meeting as well, and then we could go further. Okay. So I think, we started out basically talking about the challenges, right? Why standard, right? The agenda. And I think a lot of us here are aware of the challenge with vertical co-design. So this was just to try to make sure we capture the broader audience. So really like this thing is just, I think a lot of people here are aware of it, right? With systems, the complexity. And I'm just going to be brief here. I'm not going to read through the slides, right? And really like what we're saying is like there is, a clear and standardized way to describe the overall infrastructure that has all these heterogeneous components, how they're connected is missing, right? And this actually creates a big challenge when you're trying to design new systems, try to do like what if analysis, try to do simulations before you even write code, right? Whether in RTL or whatever it is, or even build anything in physical form. So this is really the motivation here, right? Like having that definition defined so that like, as we do code design, because you're actually touching every layer of the vertical stack, right? All the way from application down to the hardware itself, then the assumption, I mean, here is that if you have this definition, you actually aid people to do research and explorations on optimizations, right? If they know of this information, various layers in the stack could then actually, take advantage of this information and further optimize and as they design things. So at the end of the day, right, we believe it's like, really, we need to capture this diversity, the inherent complexity in a structural and machine parsable way. So this is, like, we're just trying to make sure people at the meeting understand why we feel it's important to standardize, because, when people have their own way of defining things, right, it's very hard for people to, like, say, do some simulations. And then for somebody else who may be also in the same field or same areas, want to do some other research or actually like try to turn the simulation into physical form, right? How do you actually like compare and contrast, even if like comparing results or experiments that you did in simulation versus something that you do for real or something you do for real, just basically, trying to compare different things, right? When you don't have a common language to describe the input of something, right? Like a lot of times it makes it very difficult for both the builders and the consumers of what you build to be able to do, A/B comparisons, right? Um, so really like this is like our pitch to say like why we needed to standardize something so that, hopefully the broader ecosystem have a way to actually reason about everything, right? To look at and compare and contrast different what if scenarios. So this next slide is really like, we didn't have time to actually go through the real demo that we actually show everybody here like about a month and a half back. So this was just trying to capture, in essence, right, like what was actually already been kind of coded and proven, right? That that we are able to actually combine sort of different neutral inputs, right? Like infra.proto as well as the workload sketch from Chakra, right? Combine them together and enable a lot of these different downstream use cases, right? Whether it's open source solutions to simulation or commercial offering from company like Keysight or other companies, or any other proprietary simulators who decide to adopt these kind of, neutral inputs, right? And standards, okay? And the key here is like now, if you actually define, hypothetically some benchmark on whatever aspect you're looking at over the system, right? If you have a common definition of what that sketch of the workload looks like in Chakra, you have a way to describe the system in the blue, right? Using infra.proto and extensions from it, right? You should be able to then, take care of a huge chunk of the variables of that benchmark if you want to go run a benchmark on, one environment versus another, right? As you actually portably be able to run these and then do with the A/B analysis. So at this point, I'm gonna pass things over to Andy to kind of walk everybody through, right, on kind of a bit more details on the internals of infra.proto, which I think, for this meeting on Wednesday, we actually updated our doc site for now, right, with the full documentation and, what's there. It's the link there, and and Andy could go through like a lot of those aspects. And I think if people on this call feel like some content is too deep, please like holler out so that we could sort of zoom back out a little bit, right? And then keep it at the right level. Okay, so go ahead, Andy.
Thanks, Winston. So what we did was some time back is we talked about it with various groups in ML Commons, specifically the Chakra group, and we proposed an alternate way of capturing infrastructure, and we decided on using a graph because the flexibility and the abstractness of it, and the ability to extend it as much as we wanted. So, and the ability to sit there and extract, path information, lowest cost stuff. It just seemed to naturally fit what we wanted to do. And so, the graph gave us certain constructs like nodes, edges, and properties. Now, the properties really aren't inherent in it. The key things are node and edge. We capture those in infra.proto. Actually, we expose them as components and devices. We consider those to be vertices or edge or nodes. And then edges we call connections. And that's the overall concept of how we use the graph, or why we use the graph to be able to do that. Next slide.
So in the networking terminology, we usually call these edges which you do as the links. So there a reason why we are choosing the different terminology?
Right. So as you can see here, actually the next slide, Winston. So the second point down, you can see connections or links, right? We consider a link to be the clear. We wanted to extend it so that it became clear text and that it was easily readable, but still parsable, machine parsable. And we wanted to be able to capture the ingress egress points with the link in between. And so by doing that, you could actually sit there and take a connection, and connections really define any kind of graph.
Right? Are you saying that edges are directional, the links are not?
So in this case, they're bidirectional. We haven't added any component to sit there and enforce direction at this point.
Oh, so then I think I didn't get the difference between link and edges you just explained. Then both look same, right?
Yeah, so I think the edges really was just like, I think that was more just general methodology for graphs, right? I think that's what this previous slide was meant to do, right? It's not actually part of the protobuf itself. So
in the physical kind of hardware implementation, as you guys know, we have ports and we have links. A device has ports to leave the device.
Yeah, no,
and then
exactly.
It normally uses a link to connect to another port of a different device. Now, do you mean the edge here is synonymous to a port?
Right.
There's physical and virtual as well. I mean, one of the issues.
So I think let me backtrack a little bit, right? So I think this whole thing here is about what we said about node and edge and property, these are just concepts. They're not the actual names inside the schema, right? This is just like general graph theory type of stuff, try to explain to people
Okay.
about a
So then
graph.
just, I
Okay?
thought this is a part
Yeah,
of schema.
no. Edge is not in the schema itself. There's nothing in the schema that says edge, right? So,
Got you. Okay.
So
But
these are the
CMX
things that
and-
are actually in the graph.
Right, but CMX and Prakash, to your point, one of the things that was asked as we finish is as we start to look at the terminology and reconciling with redfish or what was proposed in swordfish, or if we look at open config, what do we do to reconcile? So as we start to go through that, it'd be great to get your feedback to make
Yep.
sure that there's no confusion as we cross boundaries.
exactly, right? And I think like that's the part where I think like ongoing as we collaborate, it's about getting the terminology right. So 99% of the community for different purpose understand what those means, right?
Yeah, that's what I was
But
trying
don't
to
take that as
understand.
final. Like whatever
Yeah,
we're saying here, we're just sharing with people like what we have as a starting point. So
Yeah, and this is like in the networking field, these are kind of well-defined terminologies for all of these things. So if we can keep those things same and whatever the extension we are putting, that'll be probably will be help everybody to come on board quickly. So because they know that like, yeah, this is the port, this is the link, this is the end-to-end link. We call it end-to-end link or tunnel sometime in the networking terminology. So yeah, but we'll please go ahead. We'll
Yeah, but Prakash, to your point, and Winston took the, we have the action to follow up, is that, John Leong, he was talking about redfish in the chats as we were going through, and he said, hey, we did this for, if we start to look at kind of servers and the way we describe some of those things, and we tried to venture into networks, but the open config people really wanted no part of it. And so we've already seen kind of that, how do we have to map two things? And we don't want to create yet a third one where we, to your point, where we create these odd boundaries or abstractions. And so I think it would be good because I think Redfish has already gone through it. And so we just want to make sure we map correctly.
Sure. Yeah. Thanks.
So what we wanted was a set of messages that would allow us to create that the entirety of your AI cluster or any kind of infrastructure actually, from a small footprint to a massive footprint. So the things that so we use protobuf messages. The smallest pieces that we have are components, links, and connections that make up a device. We then take those pieces and we store them in an inventory. We use a device instance message to basically categorize a device or give it a role and then also scale it. And then we have an infrastructure message that basically acts as a container for the inventory, the device instances, and then ultimately the infrastructure connection messages that are outside of the actual device connections. So we'll actually show you the difference between those two. And the last thing that we do is, since this is kind of a physical / logical representation of your infrastructure, right? Everybody needs to extend that graph or annotate it. We kind of gave it the name annotation, right? So using the annotation proto in conjunction with the definitions that you put in infra.proto, you can add any kind of information that you want, and you can tag logical connections, you can tag logical device instances, all the way down to the component instances, or a full path with additional information, any kind of information, and it can be unstructured or as structured as you want. So anything from open config or redfish to your own internal organizational structures to capture any kind of information. Next slide. So this is a case study that we use for describing a cluster. And really what we want to do here is we want to take the textual description, right? So somebody will come to you and say, I have a scale up, scale out infrastructure with 1K hosts. Each host has 1 NPU and 10 NICs. And I'm going to have individual racks with rails with 16 ports per switch. So you're going to have a total of 512 scale-up switches. We're going to have another rail, a scale-up rail with 2 scale-up switches that's going to connect 1024 ports. And then I'm going to want 64 racks with each one of them having 16 hosts per rack and with 8 scale-up switches per rack. And connecting using, either 400 gig or 800 gig. That's typically what somebody will come at you with description. And so it's kind of abstract. And so what we do is we want to ultimately use infra.proto and end up with the diagram that you see below it. And the next couple of slides will actually go through the steps of how we do that. But ultimately what you'll end up with, once you capture it in infra.proto, you can create visualization tools, right, that will actually render the diagram that you see below. Next slide. So the first step then is create that inventory of device and link objects. So taking pieces from the diagram, right, the first thing is we said 1024 hosts. So let's just take one host. We said it was 1 NPU and 10 NICs. And that's what we gave it a name of vendor A server. And you can see the components in there. We have a link, and then we have the connections that connect all the components together. And so what you'll do at this point is you'll create as many connections as you need to be able to interconnect all the components that you decide. You can keep it as simple as possible for your test scenarios, your emulation simulation scenarios, or you can increase the complexity of the components and the links and the connections, right, depending on your needs. Once again, everything is name-based. And we'll go through why we made it name-based, right? As later on, you can actually just switch names without actually changing the content below it and still end up with something human readable. We did the exact same thing for the scale-up switch, vendor B router. We also captured one scale-up switch, which we call vendor switch. And you can see they're all different, but every one of them has the same set of messages, the components, the links, and the connections that make up a device. And the last thing that we do is in the inventory, we capture the links that we're going to be using to connect up the individual devices themselves. So here we wanted a scale-up link and a scale-out link. We gave them a name, allowing us to sit there and easily change the bandwidth, the underlying bandwidth at any time we want. Next slide.
So quick question, same question on the connection part. Is the connection here means kind of port?
Yeah, so there's 2 levels of connection. One at a device level that connects one component to another component with a link. And then we have another connection at the infrastructure level, which connects a device component. Think of it as what's your ingress egress point on each device, which we're going to connect to another ingress egress point on another device with a link in between. That's the infrastructure level. We'll show the difference between the two in a future slide.
So connection include both sides of ports. That's what we are trying to say.
Yes.
Okay.
With an instance identifier. So if you look at the component has every component has a count, allowing you to scale up inside of the device. So here you only specify 1 CX5, but a count of 10. So then your connections have to account for that. And
So
that's
let's say NIC.0 to NIC.9. These are what?
these are
On one
these
link
are
different ports, or it is the ports of the link, like both sides of the links?
It's both sides. So NPU 0 through PCIe to NIC9. So NPU 0 is connected to NIC9. So really what we have is we have one single NIC connected to kind of PCI switch with 10 NICs below it. So then the NPU, right, or for example, a workload can shard the workload, right, through individual NICs, reducing the load. You'll run into different scenarios like that, but we have to be able to capture all the paths because every workload can take, every message can take a different path.
Oh, so connections are different paths
Correct.
in the multipath. Okay.
Right.
Yeah, I think, yeah.
Basically unique paths inside
Okay.
of your device.
Gotcha. Yeah, yeah. It's just, in networking, we call it multipath thing, or ECMP paths if they are
Right.
equal host. Yeah. Okay.
So in this context, a path and a link are synonymous?
The link is the intermediate. It's the connection between individual components. So in this case, PCIe, right, it's a PCIe link from the NPU to the NIC.
And the path is a collection of several links?
Connections, we don't really call it path, we call it connections. And the connections are all the basically unique paths, if you want, from the NPU to every from one component using a link to another component.
So link is the aggregation of all the connections in this case. Is that right?
No, so I think this is the part where I think maybe as we keep moving forward, right, is the stuff we need to actually like discuss more in details to see how do we land on the right terminology, right? But the way to think about it is like, the way I think what Andy is trying to say is like connection, and I think Shamek and you guys are saying like path, right, is really about path, right? So meaning like some way to get from A to B, right? You may happen to get from A to B traversing only one link and two components connected via that link, or a bunch of these bunch of links connected by multiple sort of hop by hop, component to component, right? That makes up your overall path. So the analogy I would say is like think similar to like this, the idea is try to kind of like for example, for Google Maps or Apple Maps to work, right? When you tell it to say go from A to B, how do they route that through the highway system, right? Underneath, they must have a way to describe the highway system, right? So that's kind of the analogy I think, that maybe is the higher level analogy, and then the details, terminology and naming is something I think we need to.
Yeah, I think right
work on.
now, look to me, it's kind of confusing because link usually used in terms of the physical connections in the networks. Looks like here you're talking about links or like a link to google.com or something like that.
There's
No.
two levels of stuff. I mean,
Yeah.
there's the virtual connections that your software needs that live in IPv6 land and may not actually be attached to any physical hardware. And then there's the physical hardware network that you want to actually make those connections on. You have to try and match those things up.
So which is the physical one and which is the virtual one here? Link in
If it
link
says,
and the
if it
connection.
says something like PCIe, it's physical.
Okay.
So
But then
you're going
how
to
this
create a socket connection from A to B and layer 7 software
Yeah.
land,
So
and then you got to
I
allocate
think
that into
all
hardware.
of that, the higher layer stuff is not described here, right? This thing is really about the physical stuff, right? This
Yeah.
is trying to
You need
describe
both.
what the
You need
physical
both.
thing looks like.
You're
So
going to hand the virtual sort of channel network, which is what some of the other guys are doing with a graph of what your actual software needs. You're going to take that graph and try and map it onto the physical.
right. I mean, those are things you kind of bind those additional data on top of this, right?
Yeah.
This is
And
really defining
in
that
a data
like,
center, you may have to do it and then undo it and move things around. So these things kind of need to be more dynamic than people generally, consider when you're talking about these things.
I think right now it's a little confusing for me to understand the difference between link and connection. Link, if it's a physical level, then connection is at the port level. Because it looks like NIC.0, 1, 2, 3, 4, 9, these are 9 ports.
Well, there's a network discovery thing. One of the things we're talking about in the other stream is like, can we talk to the network? Can we ask the network what its structure is, and you get this kind of graph information from it.
Yeah. So I think what I would suggest is like Prakash, that we, this is good, right? Because we're looking for confusion, and then I think we, Pradosh on our side will take that down, and then we would follow up with you offline and then really try to go through it, right? Because there's I think the point here is like we're trying to set up the background, so confusion is actually what we need to hear, right? And work offline to reconcile it. Okay.
Yeah, I'd like something that just tells me what my home network looks like.
So yeah, so I think we got about another 18 minutes left. Okay, so can we keep going? So
Yeah,
that way, like Andy could cover the the broad spectrum of the high level, and then I think we need separate sessions, like to go in deep, right? To resolve the it's not it's like I don't think we're ready to resolve all the terminology on this call. So
Yeah, I also think it'd be better to let's just push through, because I also have a bunch of ideas and comments, and I think we
yeah.
probably just need to collect them afterwards and then work together how to bring them in. But for now, let's get an overview.
Okay, go ahead, Andy.
So the next step then actually would be to take those individual inventory devices and assign scale and roles. So in this case, we've taken the specific devices like vendor A server, and we've given it a name of host, right? Because you want something agnostic, and here that's where the count allows us to assign scale, so we can actually scale up the number of hosts. Remember, it was 1024, 512 for the scale of switches, and 2 for the scale out switches. And that's what the device instance message is used for. Next slide. Then what we do is we basically build the entire graph with a list of edges or connections, or actually paths. I kind of like that, to connect those devices. So here at an infrastructure level, the connection or path becomes a lot longer, right? Because what it is it's the ingress egress point on each one of the devices that we want to use, and we connect it in the middle with one of the links in the inventory. So for the items that we see on in the rack, connecting to the rack rails, we'll have for starting at the left, we'll go from host 0, NIC 0. We'll use a scale up link, and it'll actually connect to scale up switch 0, port 0. And then we just carry that through for all of the rack connections. And so we do the same thing all the way to rack 63. So here you connect host 1007 using the same scale up link, but you can see the increase in the scale up switch. And in the green, what we do is we connect the remaining 2 NICs on each one of the hosts to one of the scale up network switches on the other rail. And so the connections will also include, for example, host 0, NIC 8, using the scale out link to the scale out switch 0, port 0. So effectively what we've done is we've captured the diagram in that first slide using infra.proto, and we'd be able to render that full diagram using visualization tools. Next slide. So this is the point where every user will want to start extending it, right? So you have this physical/logical representation, and you want to start adding your own information. Some of the information that you end up adding is, for example, metrics and telemetry. And so the annotation .proto allows you to sit there, and like I said, so if you look at the connection, right, you'll see that you have things like host.0 or host.0.npu.0. And so you can assign information to any one of those points. So at a very detailed level, or at a very global level, all the way up to the infrastructure level. So for example, individual metrics and telemetry for host 0 and NIC 0 could be captured and identified using annotation. So you get a direct correlation between that graph and your own custom information. Other things that you can include would be things like impairment, data movement, explorations. So for example, if your devices were detailed enough to include information like NV switches, right? You could then sit there and look at alternate paths. For example, you could explore, what if I wanted to do a PXN type of test, right? Movement between GPUs and then to the network through rails, right? This, or just use your traditional straight through the NIC into the fabric, right? There's by capturing more detail, you get more ability to do more detailed what if scenarios. Other things that you
is this proposal, or is this what your network hardware does at the moment?
These are things that well, Keysight currently looks at, right? Because you have options of using either NVLink or using.
So again, right, we're just listing out what possible things people might want to use this information for, right? It's not a product pitch or about anything that's.
Yeah, I'm just wondering, you know, if this is your hardware, is there a way I can just query your hardware directly for this kind of information?
No, there's not. We're not talking anything about hardware or our products. So
okay.
We're just saying, like, for example, right? Like for the first point, right? Like what I mean by this is like, if you look at metrics and telemetry, right? There's a lot of different vendors or even or hyperscalers that provide telemetry. We don't go, that's, you know, like we as a company don't do that, right? But if people have telemetry systems, they could actually inspect the graph in InfraDot Proto and put a tag on the particular metric so that, you know, if they want to use it for monitoring purposes from the monitoring tool, if they see some anomalies, they can look at this tag and, oh, this is what's happening in the infrastructure, you know, blah, 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 right? We're just outlining possible use cases.
Yeah, I mean, part of the stuff in the other work
it's not what we're doing.
Yeah.
Right? Like,
yeah, but part of, I was wondering if you were doing it because we're trying to do some of this stuff on the other work stream where, I mean, my proposal is that you make stuff smart and you can ask it what it does. And it would give you information like you had in previous slides back that your tools can then work with.
Again, these are just possible use cases.
Yeah.
Right, so for example, on metrics telemetry, I could actually sit there and assign GNMI structural information that I may want to pull back along with the location of where that endpoint is, right? And then because you've identified it as GNMI, you'd be able to sit there and use that information and then attach the results to the actual endpoint itself, or the correlated information.
Yeah.
Some of the other things, for example, workload graph, scheduling information, we could add that. We could tag it to the actual graph itself. And then, for example, the example that we gave had compute and fabric, right? However, there's nothing stopping us from extending it with storage nodes and clusters and disaggregated memory clusters. So for example, the devices that you saw, right, that we captured 3 devices where there's nothing stopping us from adding a storage device and then storage links and storage fabric, and then expanding the actual graph itself. And then the workloads that we see also have checkpointing to be able to store intermediate information, right, and then continue on and maybe revert back. So these are all possibilities that the graph can accommodate.
I have actually a question here when you talk about extension. So if you have a hardware vendor who actually has a device, kind of like, is there a way of using that description and then suddenly add that to the schema and it makes available for others to integrate into their infrastructure? Is that kind of like the plan that you actually say, here, you have a new device, whatever, just give me that protobuf sub protobuf, and then that gets sucked in, and then we can actually create this infrastructure by collecting these different pieces. Is that the way you're thinking about or not?
I'll let Winston field that one. Or maybe not.
I mean, yeah, I mean, I think the key is like we provide the base messages, you know, very much the same way like Chakra actually provide you the base primitives. And then, you know, it's up to people to how they want to compose it together to form a, you know, more specific concept, right? And I think the idea is that if that specific concept becomes now a very like wide adoption or a common, you know, trend, right? Like in the ecosystem, then you would consider actually promote that as a first-class citizen into the schema, right? And this is why it's like evolving the schema is really iterative work that, you know, at the same time, the schema needs to be flexible enough to allow people to innovate and do a lot of what ifs, which may be one-offs or very proprietary. Or when things become more sort of commonly understood, then promote that to first-class citizens. So people don't have to re-roll different versions of the, you know, things you could try to do like, you know, just very flexibly, right?
I was looking to get something where, you know, you could just query the router as to what it is and what capabilities it has, you know, because they're getting to be quite, you know, powerful things, you know, with quite a lot of processing capability with FPGAs and stuff. So I'd like to use that.
Yeah.
Yeah, so I think, Kevin, to your question and to Ulf's, it's an area, if you look at to what Winston and Andy have been discussing, hey, can we have the schema, which allows us to also kind of feed into the model. And one of the areas of the modeling, in talking to Tushar, is can we actually have things that would look a little bit more black box or something that we don't have to be fully descriptive in terms of this, but it allows us to discover it, to attach to it, to understand what kinds of things. And then if we have to feed into the model, you know, how it gets consumed and things like that, but we don't expose. So two things. Number one, you don't have to be fully descriptive, but number two, you don't have to disclose some of the internals that you may be doing when you model. So it gives you enough of a connection handle. And I think that's an area that has been requested in the AstroSim space. And so if we could discuss that with Winston and team about a way that we actually have a hook without actually being fully descriptive in terms of the schema, but allows us to make a connection.
Part of my proposal for the Ethernet stuff was that we have like a virtual network, a VLAN, in which things can announce themselves and you can see what you actually have available to you in hardware. And then you can go query it about what it's connected to, and then you can build a graph from that kind of information.
Well, the self-discovery is very hard in simulation. I think this schema is really helping us when we don't have the devices. You can't query the device. Who are you? What can you do?
Yeah.
To actually have that. So I think this actually goes together. I mean, you can actually do your discovery and then create a schema, fill that schema based on your discovery.
Yeah,
So
I mean, your discovery could,
But
yeah.
we have discovery stuff for networks and computers, you know, it's DHCP
Exactly.
and
Yes,
DNS.
of course you do.
It's missing a couple of hooks, you know.
Yes,
No,
but
I
the
mean,
point is, this is the future network that doesn't exist yet.
It's like what offset, right? It's like you could actually, you know, update your discovery tool so that it spits out the schema, right?
Yeah.
Whatever the schema we define, right? Or if you try to build something new, you know, you could then go start from the schema and then, you know, so it's kind of flexible to be
But I mean, the
integratable to
routers,
different things.
the routers themselves only know what they're connected to directly in some extent, you know, but they don't really know what's beyond the next router. You know,
maybe based on this conversation, it is not clear the input to this tool and the output of the tool. If you can maybe summarize that once more.
So I think the thing is, right, it's not about the tool. This is about the format of the language, right? Which is flexible enough for different tools to adapt to, right? And then the tool could either be, you know, spitting it out in this format as output or consuming it as an input or both. We're not dictating what the tool is, right?
So CMX, they actually did a demo where they created their own tool, which would generate, you know, based on some of the input, would be able to use this to do the representation. But I think to Winston's point, it doesn't dictate, hey, the tool shall be this or things like that. But it does say, hey, if you have a tool which represents a network, we have a schema that we could output based on, you know, what you did from your tool. Is that correct, Winston?
Yeah, I mean that or vice versa, right? Or you start with the schema, and then if your tool or network simulator understands that schema, then you could consume it, right? And then just run the simulation based on what the schema tells you, right? Vice versa, yeah.
Yeah, you know, the nice thing with the tool, if you have the kind of the visual or whatever you did, generating the schema, but sure, we could generate the schema, we could go through and do that, absolutely.
So it's a really engaging discussion. We got like 2 minutes left. I'm gonna maybe move through this very quickly. So I guess touching on what Jack said, right? This is what we did, I think a month and a half back, showing how we actually use infra.proto and map it to AstraSim, right? And NS3 to basically say like, hey, AstraSim, you know, I need you to actually play back like a collective workload along with this particular shape of the fabric topology, right? Defined via infra.proto. And the AstraSim as a tool get you back results about the, you know, completion time for the collective communication and things like that, right? So in that case, the tool is actually AstraSim, right? Consuming both Chakra workload as well as infra.proto. So I think that's pretty much it. I think we probably need to, you know, so I think the key thing is like, if there's a lot, you know, it sounds like there's a lot of interest, a lot of good feedback that, you know, we should figure out a way how to do this, right?
I would say
consistently
yeah.
in a different stream, I guess. Yeah.
I would say with these sort of things at this point, I'm proposing meta standards where you say, okay, this is what we're doing, this is how it maps to a higher level, more conceptual thing. And you
So
get
where are you
agree to the
proposing those?
conceptual level.
Kevin,
Pardon?
where are you proposing those?
If you're doing something like this where you actually have a protocol or, you know, schema, you need a higher level sort of thing of saying how that maps into what everybody else understands, because like nobody reworks their stuff usually. So
I understand. I didn't know if you had a formal proposal that you were moving towards standard or.
well, I mean, I've got the graph GVM, you know, the graph virtual machine people. They want to do their stuff in their language, you know. So okay, like let's work out what all the concepts are, and then we can describe how they map from one thing to another. And then
So is that in OCP or is not in OCP?
I would do an OCP. I think OCP is the only place you can do it.
Okay, so we have so you would do it in OCP. So we're going to do this in OCP. So as we build out to your point, the proposal for the standard, which is essentially the specifics, if we need some sort of meta hierarchy, you know, framework kind of thing that would go along with this, we would need to, as part of the call to action, we would need to do that as well as reconcile with what Simek and Prakash were talking about, and you know, how do we align? What kinds of things do we do? Where do we connect? You know, how do we get the language great? So Kevin, we'd have to, you know, if we need that to include, then let's make sure we include it so it's comprehensive when we move forward.
Yeah, I think the thing I would say is, you know, I see people doing products and it does something. You know, if you come to the committee and say, this is what our product does, it will give you this information in this format. And then we say how that maps into, you know, stuff for other people.
Oh, okay. And so the only thing I'm saying is, as we move forward, we'd like to be concrete, but we'll tackle this, Kevin. We'll tackle it as we go ahead.
Yeah,
Okay?
It's more like formal translations
I
between
think
the forms that people are giving you.
So Winston, do you want to you're the point of contact. So do you want to put your email into the chat, and I'll make sure I send it out to everybody as we kind of get things going, and let's use the email over the next week or so to kind of get thoughts together. But Winston, you know, you'll run point. We'll see what we do and what actions we have to tackle going forward. But I'll connect with you offline. We'll make sure we get it.
Yeah, I mean, I pasted both Kinshuk and my email there. Most likely it'll be us sort of combining, try to do this. Because I do have other day job, right? Like stuff to do. And my preference is like, yes, you know, like I think, you know, like try to cover as much as we can, but I kind of resonate with what Jack said, right? I like this to be concrete, and also just, you know, really try to apply it, right, to something that's more like we want to vet or something like that, versus do a lot of breadth level, you know, like touch points, and then none of them is concrete, right, in terms of using it and applying to a simulation tool or whatever it is, right?
Okay, so let's you know, 'cause we're a little bit over time here, so
Yeah.
let's we're gonna work, I think, Winston, to gather some comments. People had comments, things like that, pull it together, and then just say, okay, what's a plan? And propose a plan that, you know, we can bash the plan, and as long as we have a plan, then we can figure out as a working group. This isn't like Winston and Kinshuk and Andy, you know, rolling up sleeves and saying, hey, please do. You know, how do we work together to kind of make sure we have the right connections? But to your point, let's get a concrete plan and kind of go forward from there.
Sounds good.
Yeah.
Okay.
Thanks so much, Jack. And
Hey, I'll connect with you offline about, you know, or if we can include in the plan about, you know, connecting to Black Box as well as Kevin, you know, how do we get a framework for, you know, an infra proto schema handle? So if now we can populate values based on what we auto discover. So we have some couple of actions we'll kind of iron out that we want to make sure we include in the plan.
exactly. I think it's extremely timely right now.
Yes. And we're seeing other people come up and say, hey, I want to have pictures. I want to go through.
Yeah.
And when first sentence he joins in, he goes, fantastic. I want to use that. So we have some customers.
So like we run into each other a lot, right?
I
Like,
know.
if you're interested, you know, Kinshuk and I will be happy for you to
Absolutely.
be with us, right?
Yes, I think we should actually have a
driving
meeting
us.
offline. Absolutely.
Yeah. Okay.
Winston,
Right.
thanks so much. No, but
Right.
really, Jack, this is the right forum here. OCP is the right place.
Okay. All right, we'll go forward. But as I tell everybody, we're going to do it as part of open, and we're going to submit it in terms of that. But okay.
Oh yeah, absolutely. That is absolutely, this needs to be open. And as I
Okay.
said earlier, I like to see a marketplace of components later to the schema.
Yes, sounds good.
Thanks.
Yeah, this aligns with the AI fabric as well. So good. So
Perfect.
Yep.
Okay,
All right.
that sounds
Thank you.
Thanks,
Thanks.
everybody.
All right.
Thank
Bye,
you.
thank you.
Andy.
Impressive work, guys.
Yes.
Really impressive.
Yep.
Bye.